My presentation is pretty much very similar to the structure of this study. First, I will give you an introduction of this system and present the literature review and the proposed framework. And following that, there is a case study using 10 similar contracts as samples to do text analysis in the proposed system, and finally there comes the conclusion and candidates. So as you know, contracts are one of the important types of the documents for generating the auditing evidence. Currently, auditing all the samples are based on the sample base. That means to say not all of the contracts are analyzed. So in this case, the disadvantage is that some of the samples will not be audited. In other words, the samples cannot represent the whole population. And according to the revenue contracts with customer regulation, it requires 5 important steps in auditing works to audit all the contracts. The relative steps are primarily 5 steps related in this requirement. So the system proposed in this paper is called Automated Contract Analysis System, short for ACAS, and it has 6 major parts. I will introduce these parts in detail later on. This paper has 3 contributions to the current literature. First, this paper demonstrates the feasibility of the proposed ACAS system. And second, this paper provides a cost-benefit efficiency solution for the problem of auditing the higher population of contracts. Third, this proposed system incorporates linguistic audit and analytical tools in order to help auditors to adapt to the era of big data. So basically, prior literature has demonstrated that the use of text mining is very useful in the auditing works. For example, prior researchers have literatures regarding to the keyword extraction from news articles and the information extraction technology, text abstract summarization, and the text categorization using machine learning. And furthermore, there are also literatures adapt text analysis technology to the accounting works. So this is the proposed ACAS system, automated contract analysis system. It has 6 major parts: content extraction, valuation,
this one and another one. I don't have
detection,
because I don't have access to Blackboard enough.
Related field identification, and the log information. For the first part is the content extraction. It helps to identify and tag contracts to any related specific audit tasks or procedures. And the second part, content extraction. This part of the system can extract the audit-related information from the contract contents, including text, numeric data, and tables. The third part of this system is valuation. This part of this system can help to identify and extract information related to fair value measurement. In other words, this subsystem helps to judge the fair value of the entire company. And the next part is fraud detection. This subsystem aims to identify potential fraud activities from the contract analysis. Basically, this subsystem can help can use the, for example, in my opinion, is to use the dictionaries of the negative words and to analyze the amount of the negative words in a dictionary to detect the potential fraud in the contract. The fifth part of the system is risk analysis. So this subsystem focuses on analyzing potential risks embedded in the contracts. I think it's similar with the fourth subsystem, fraud detection. And the last subsystem of this proposed system is log information. This part of the system can help to track the different versions of a contract at different time. In auditing works, there are three primary steps. They are planning and the risk assessment, compliance, and the substantive test and review. These three steps are involved with contract analysis, and the column listed here are the traditional procedures in these three steps in auditing works, and and all of these steps can be done using the proposed system, Textual. As you can see, that all the traditional steps are time-consuming, right? So once we embed the automated contract analysis system, all the works can be modified and less time-consuming. So case study. In the second part of this paper, it follows a case study to demonstrate the feasibility of the proposed system. The samples used in this study are 10 similar contracts. So what is similar contracts? Similar contracts are the contracts that are generated from web template. The similar contracts are widely used in insurance, house renting, etc. A lot of fields, right? So 10 contracts are reinsurance contracts. Reinsurance, I think, is the insurance of the insurance companies. They are reinsurance contracts. Okay, so the case study here first measures the similarity between different contracts. So, how to measure the similarity in computer science? A widely recognized methodology is to use the cosine similarity score to measure the similarity between different contracts. So in this paper, cosine similarity score is used. And the second step is considered on how to extract the information out from the contract. In this paper, regular expression is used in order to extract the useful information. I think this is a regular expression is a topic that we will cover today, right? And so data pre-processing. Among the 10 contracts, the first contract is regarded as the template, and the remaining 9 contracts are the similar contracts created from the first contract, the template. And in the second, in order to demonstrate the feasibility of the system, the author manually made some errors in the second contract. The first error in the second contract is to delete one of the paragraphs, and
oh, I'm sorry. I just want to ask about the cosine similarity part.
Yes.
Like the reason that why we use here is because like the basic cosine similarity theory is like having two axes.
yes.
Like these are the two words each other, and like, we make multi-dimensions and get the relations between like all the words and like many of the words. That is why we got the representation part, not the like relations between the words, right?
Representation part?
Yeah, like representation of the document.
Oh, yeah.
That's right.
What you're saying. So you have the cosine similarity takes.
Yeah, it's like the
two
basic
vectors of
similarities,
words.
two vectors of words.
So like the word, all the words in their word counts.
So they have all of those relationships.
Yeah, those are all the
vectors.
Yeah, those two vectors, right?
So and then we get the score.
And then
That's
you get
what
the
it's-
similarity score between those. Yeah, I'm an expert in cosine similarity, right?
What?
You're an expert in cosine similarity.
No, I can't say that because all I did was import a library and use that.
We're going to go over in detail in another class.
Okay.
After mathematics behind it. Basically, you're taking a document and you turn it into a vector of words, word counts, and then you
Yes.
function.
Generally, in order to compare the similarity between text, cosine similarity score is widely used.
Text.
Yes, just text.
In this case, it uses for
Yeah,
text.
especially in this case. All right. Where was I? Oh, okay. I just mentioned that 2 errors were manually added into the second contract, right? The first error is to manually delete one of the paragraphs. And the second error is to manually add a irrelative paragraphs to the second contract. And furthermore, another sample contract, number 11, is used. This contract, number 11, is not created from the template. So this contract is totally different from the contract number 1 to number 10. And first of all, this table presents the the similarity between the sample used in this analysis. All the similarity scores are cosine score, which I just mentioned. As you can see that the first contract is regarded as the template, therefore the similarity score between the first contract and the template is definitely 100%. And contract number 2 to 10, as I mentioned, they were contracts created from the template number 1, contract number 1. Therefore, you can see the similarity score between number 2 to 10 and number 1 are quite close at 99% level. And as I mentioned, that the last contract used in this research, number 11, was irrelative, not created from the template. Therefore, the similarity between the template contract number 1 and the last sample contract number 11 is quite small, not close at all. The similarity score is only 32%. Okay, next, this table presents the results extracted from all of the contracts. These results will.
Yes, yeah. Can you just go back to the last slide? Can you go back to the last slide? So something I wasn't sure about here, is this only used to see if documents fit the same template or what? Because you have document 2 there with seeded errors, but the similarity score is higher than documents 6 through 10, which are supposedly not.
Oh, I will talk about this difference later. Generally, that is because of the low image quality.
Okay. Is there?
Yes. So
there's no discussion in the paper though about how, like, what is an acceptable threshold? I mean, 32%, obviously that's much lower than the rest, but where do you like?
Yes.
yeah, as you said, there's no threshold in this paper, but generally, as we can see, which similarity score is high and which is low, we can, because the number of the samples is only 10, so we can, I think we can visually scan all of the scores and get the conclusion. These are the results extracted from the from all the sample contracts. But as you can see, some contracts didn't have the extracted results. For example, the policy number of the 6, 7, 8, 9, 10 contracts are NA. That's because as mentioned in the paper, this is because of the low image quality that the system cannot recognize the OCR results from the low quality PDF files.
So like, how bad was the quality of the PDF? Was it like really bad? Not readable? Or
well, that are the contracts from one of the big four auditing firm and one of their client. So, and the quality was that if you get a paper and you take a picture with your cell phone and then upload it to a website, because it compress that, right?
yes.
So compress that, and then if you download that compressed picture, that's kind of like the quality of that.
Actually, during our like data mining course, we just learned last lecture, like the professor, he just told us that there is a lot of like reversing technologies.
Yes.
Like from the low dimension qualities to the high qualities. So he just told us that it was quite a very simple process. However, couldn't you guys like use those kind of process? Just told us that's very
Yeah, that's actually a very good idea. And when we are doing that, I haven't thought about that. So that's a good, but I mean that part we are going into another big area, a literature area of using that like, kind of document recovery, right?
recovery.
But I'll see if there's kind of already built software we can do that.
But I'm not sure about the cell phone photographs.
Oh, so I'm just giving example. So if you think of when you are on the Ruggles copy machine, and if they are using some old copy machine, then they have the dirt and they have all the stuff on that. It gives you a low quality image, rather than currently if you download a paper on a AAA website, and it will give you a PDF file that contains it's already OCR, or it's already contains a textual. But sometimes you'll get, if you look at paper published in 80s or 90s, they are kind of image rather than give you the text. And there's also the image is kind of broken somewhere, because when you are scanning that, it's curved rather than flat on the screen. So
The OCR doesn't read those.
no, so it will give me errors. And if the contract is 10 pages, I can edit it manually. But the contract is 60 pages, then it's kind of hard to do that.
So how
But-
did you embed it as a noise?
But
Embed as how did you put that as a noise? The paper says that consider as noise.
Because the nature of TF-IDF does not look at the order of the text.
Order.
So when we apply this, it will not like because the contract is like a 2 columns. So on the page, it's not contract from beginning to the end. It's like a 2 column, 1 column here, 1 column here. So when it's recognizing that, sometimes it will put words at random. If you transfer that to text, then it will put words in random locations. So that's why later you'll see when I do the page by page, there's strange patterns there. Yeah, but for that noise, I mean, for the overall, it's fine. I mean, if we just try to identify whether the template is of the same template. And for the regular expression, I think the OCR part did actually did a great job, especially when we identify the useful information we want to extract. So the noise does not affect that part. So what we did is we just leave the noise there and proceed our case study.
The next table of the results shows the similarity of the page-by-page comparison. And as I mentioned, that the second sample construct here has 2 errors manually added. So you can see that this outlier and this outlier are all from the second sample. These two outliers represent the two errors manually added to the construct. In the first outlier, it represents the manually deleted paragraph, and the second outlier represents the manually added paragraph. And these are the page-by-page similarity comparison of the sample 2, 3, and 10. The similarities between sample 4, 6, and 8 are quite fit with the template. Therefore, for conciseness purpose, the results of these three contracts are not displayed in this paper. And this is the results, page-by-page comparison results of the sample 5, 7, and 9. And as we can see that there are a lot of outliers in this comparison results. These outliers are all resulted from the low quality of image, as mentioned just by the author, our TA. Yeah. Okay, so at the last part in the discussion of this paper, the limitations and the conclusions. The first limitation in this study is that the case study is also it's only applied to similar constructs, but for the non-similar constructs, it seems that the proposed system doesn't work very well. The second limitation is that, as we mentioned a lot of time, the image quality needs to be improved. Perhaps the idea that you mentioned is a very good suggestion for the potential development. The third limitation is that the more potential applications of the proposed system will be discovered. For example, there are not many other subsystems proposed in the proposed framework. For example, fraud detection, risk analysis. However, the feasibility and the use of these systems are not demonstrated. And the last limitation is that only 10 contracts are used as samples in this research. Maybe in the future we can use more samples to show the demonstration and the feasibility of this system. And I have a personal suggestion to this paper is that the similarity comparison, there is no threshold mentioned in the paper. For example, by visual scan, we can see this point is definitely an outlier, but how about this point? Is it an outlier or not? Or for example, when this point is a little bit higher to here, is it an outlier or not? It's very hard to tell because no threshold is mentioned in this paper. Okay, so
Abby has a question.
I think having a threshold is a good idea, but I suggest to further consider the content of the, for example, if someone manipulates some number and manipulate that number, maybe the similarity is still like 99%, but that number will cause huge problem. I think this kind of
Yes.
should also be considered. Like,
Yeah.
Just
not
like
only threshold but also some quality stuff.
Yes, because
Also,
the
like,
quality is the most important.
like statistically outlier, like theoretically, what you learn from the textbook is that we have to detect outliers from like interquantile range. I'm not sure. Like they used to something like quantile stuff, but then like pick up the outliers from them. Like however, when you just can see the pictures, definitely like upper like 90s, it couldn't be an outlier, but however under that, it's kind of outliers in it.
So, so actually, when we, so it's two different steps. So first step, we would extract all the numbers. So the numbers you mentioned, if let's say the reinsurance contracts, one important number would be premium covered, right? If someone tried to commit fraud, changing the premium cover to, let's say, 10 times than the original number, then we cannot identify with this. That's why we first use regular expression. We let auditors to go over the first contract and extract and identify where he thinks the number is important and where the fraud might be embedded. So then we build regular expression to extract all the numbers. So present in the table. So if someone changes the number, auditors can identify through analytic procedures on the table, extracted table. And for the similarity score computing here, the page by page is for template check. The way we did this is because although the contract is generated by template, sometimes the most common issue would be someone tries to avoid the litigation risk, so just delete one responsibility to the company, and they just take that away from the template, or they will add more stuff to the other part of the contract to give to let the other party of the contract to have more responsibility. So that's the way I kind of think of potential fraud for the template. So that's why we built this page by page template check. So in that way we know whether the template has been modified rather than the specific number has been modified. And for the outlier, it's kind of hard to set threshold, a generalized threshold for the template, because every set of samples are different. It's different. So for now, I have these 10 reinsurance contracts, and you will see it will be the lower one will be 70% because of the OCR error. But however, if you look at other contract, for example, the contract only with 5 pages, then it would cause and if you modify content on that contract, it will cause a significantly lower similarity score on there. So it's kind of set a generalized threshold for that. But when we are doing this project, I just find that visually I can already identify them. So it's rather than set this whole process automatic, we still need like human judgment on the top level. So when they see this figure, so they know which page may be involved in potential fraud, and they know which page to go over.
But this is very obvious.
Yes.
So then I guess I was just thinking on a visual perspective, presumably like a page-by-page comparison. You take a paragraph out of page 2, right? And that starts, unless you're putting like a page break in, it starts bringing figures and stuff up through the contract, right? Things get shortened up. So page 3 is going to be a little different than page 3 in a standard. But what if there's an issue on page 4, a separate issue, and because of the change in page 2 and everything shifting, it looks like it's a kind of a carried over.
So you see there.
Right, but then, so I guess I'm wondering is that how do you identify that specific page, like the specific points? Because if I just note that page 2 is the initial point of concern, what if there's something on page 3 as well, and it just looks like the effect of page 2 having kind of pulled text up? Maybe I'm not totally understanding the comparison between the two pages, but I would just be worried about like a.
So the page comparison is compare each page of the sample contract to the template.
Right.
Template. So the sample contracts page 1 will compare to template page contract page 1. So if you are seeing here, that pattern is actually caused by what we mentioned. So when it's recognizing the content, it's recognized some part of the maybe I think about 15, 12. They kind of mess the content around, but because they all have the same kind of patterns, behavior patterns, so the content there is, for other contracts, they don't have this problem. The similarity score is high. So on that page, they kind of fit with the template. For this kind of contracts, the one you mentioned is recognizing the content in somewhere else and affecting the later content.
Right.
Page later content on the page. That's why we see this is kind of messed up here.
Yeah, so if I just deleted something on page 2, just deleted a paragraph.
You just delete that.
And things move up, right?
No.
So the text would.
No, thanks to the contract. If you read the contract, at the very bottom of the contract, it will say page 1 of several pages. So if we just delete one paragraph, it will not move up. We are not splitting page by the word. If you open Word, right? Open Word, it will say page 1, page 2, page 3 to you. But the way we are splitting that, the contract is we splitting by at the end of each page. It will write a note saying page 1 of several pages. So we identify that.
We're saying the content.
Like, let's say you have template, right? Contract
Yes.
1. It says page 1 of whatever.
Yeah.
And then they work on contract 2. They start from the template, but on the first page, they don't need the first half. So half of page 2 gets on to page 1.
Oh, it will not. Oh, I see.
And then what
half
happens?
of page 3 is on page 2. Half of page everything
So-
If
shifts
you're
up.
comparing template page 3 to page 3, because there's a change on page 2, there's a shift. And then what if I also change something on page 4?
So what you mentioned is more like a customized contract. Usually, for this, we are kind of limit our research in this similar contract, because usually for the similar contract, it's generated by just putting variables in a template, right? What we are talking about is more like a customized contract. So if the vendor, I've seen some government procurement contracts. So the government and the vendors will work together to modify the contract from a template. So even though you'll see, for example, New Jersey government is purchasing from vendor A and vendor B for the same product, for the same amount of product, same price, the purchase contract can be different, because the government and the vendors are working together to modify terms in the contract.
I think I'm just wondering about the specific scenario that the error that you introduce is removing something from a template. So if that happened twice, small removals, not like a
Well,
whole.
it's a removal and revision, that's why we don't see that.
Right. I'm
Well,
just
they're on
wondering.
different pages.
Yeah, but
Yeah,
I'm
but
done.
if you go back one slide, you can see between the two pages it dips, but I see what you're saying, but it's not as noticeable as what I was trying to see.
But I mean, if what you said happens there, if they just remove half of page of page 1 and all the later page has moved for half of that, you will see a consistent pattern, right? A strange pattern for that one.
So then I was
So-
wondering is if someone made a smaller change later down the road, would you miss that error because everything had a consistent error and maybe there wasn't as much notice there? Or if there was a line break or something in the formatting, so maybe that gets missed because I'm just wondering, because I know it's more of a formatting question than it is an actual text comparison, so I'm wondering if there's a better way to identify where pages from the template start instead of just saying page 1, say
Yeah,
look
so
at a text point.
actually that's why we know the reality is complicated.
Oh, yeah.
So that's why we don't build this whole thing to a very automatic way. The objective of the system is to identify those abnormal contract.
Right.
So if you see there's a consistent strange pattern there of that contract, for the auditors they can pick that up and see if there's errors or fraud related to that contract. But If without this, then auditors would just take samples and they won't even notice.
But here, let's get the end. But yeah, we should put in the paper
Okay.
the limitations of this analysis.
Okay. Yes, I will.
Let's not oversell it as let's just say, you know, if the template is strictly followed and only words are changed or only the fields are changed, then this type of analysis works. But either
Okay.
way, this type of analysis would show us if they strictly follow the template or not. So I mean, it's useful in all basic tests, but let's not oversell it
Okay.
either.
All right.
Okay, and my second suggestion is that
Oh, you have a second suggestion?
yeah,
Can you do it in 30 seconds?
as I mentioned in another class, is that the visualization methods could be modified, perhaps. For example, you see in this paper, there are only 10 sample contracts I used. But for conciseness purpose, the page-by-page comparison, similarity comparison is not displayed. So for 6 contracts, the author used 2 diagrams to compare the similarities, the first one and the second one. In the future, maybe the amount of samples increases from 10 to perhaps 100 and 1,000. So in that case, how to use visualization tool to compare the similarities between different contracts is a problem. Maybe you do not have enough space to display the visualization here in the paper. Okay, that's all of my presentation. Thank you.
Well, good morning, everyone. Today I'm going to present the second paper, Textual Risk Disclosures and Investors' Risk Perception. Essentially, what this paper does, it examines the content of risk disclosures using per code to see if the disclosures have any impact on investors' risk perceptions. There's been a lot of criticism of financial reporting, especially suggesting that the disclosures that are provided by management do not provide any useful information. So regulators have responded to fluctuations in the market by encouraging corporations to make more meaningful risk disclosures. So what the authors want to do in this study is to investigate how informative these textual risk disclosures are in the 10Ks that were filed from 1994 to 2007. More specifically, they hypothesized that informative risk disclosures are going to change the users, investors, or other interested stakeholders. It's going to change their risk perceptions, and we're going to see that they argue that there can be 3 different arguments: the null argument, the convergence argument, and the divergence argument. So these are the 3 arguments that they have on how risk disclosures impact users' risk perceptions. The null argument, this is just a null hypothesis that risk disclosures don't provide any useful information and that this is not going to cause any volatility, which is the problem for users' risk perceptions. The second is the divergence argument, which essentially says that these risk disclosures are informative and they actually provide new information about uncertainty or new risks that are related to the entity. So in this scenario, we would expect that the relationship for risk disclosures would be positively correlated to users' risk perceptions, which is measured by trading volume, return volatility, and analyst forecast revisions. And then for the convergence argument, the way that I understand it is that in this case scenario, the risk disclosure disclosures, they're still informative, but they're essentially clarifying what investors already knew, what users already knew. So this is where we would expect to see a negative relationship where we have more risk disclosures, but we have less volatility in return or less trading volumes. This study uses a changes analysis to see how annual changes in risk disclosures change users' risk perceptions. They say they use a change analysis to mitigate omitted variables that the model may be missing, or other endogeneity concerns like reverse causality. But essentially, they use a change analysis to see what is the incremental impact of these disclosures. Because a lot of companies, they are very likely to report the same risk from year to year, and there's going to be only a few new risk disclosures that are going to be disclosed. This study, what their contribution is that it contributes to the risk disclosure literature by investigating whether and how these risk disclosures can be informative. It also contributes to the textual analysis literature because it documents how users react to textual risk disclosures. For their hypotheses development, they say that the main objective of financial reporting is to provide useful information to the users of financial statements so that they can make educated financial decisions and provide useful information that can help them assess the amount, the timing, and the uncertainty of future cash flows. Prior literature has also suggested that risk disclosures have the potential to increase, which is the divergence argument that we talked about, and it also they have the potential to decrease users' risk perceptions, which would be the convergence argument. Several standards either require or encourage companies to disclose uncertainties, and they require, like the SEC or the PCAOB, for example, they require that either companies or auditors make meaningful risk disclosures. But from the entity's perspective, what is meaningful is difficult to define. And there's a lot of room here for circumventing what I would think would be useful information. So what financial authorities want to make sure is that users have useful information that can help them make decisions, and not for the entity to provide some kind of standard template that doesn't provide any useful information. But clearly, companies can circumvent this requirement. And in the paper, there's this example. Our company may not be able to implement its growth strategy. Well, what exactly does that mean? If this sentence doesn't provide any context, it really doesn't tell me anything about risks that I may already be aware of, or risks that I don't know anything about. So that's the point that they're trying to prove. There are some papers, 2 papers, that examine the informativeness of risk disclosures. The first is a Lee 2006 paper that documents that there's an increase in risk sentiment in annual returns, and that this is associated with poor future stock returns. And the second is the Campbell et al. 2011 paper that finds that the length of the section 1A, which is where the entity disclosed risk, the risk factors, is associated with low bid-ask spreads, high beta, and high stock return volatility. What this study wants to do is they want to extend the risk disclosure literature to investigate how changes in textual risk disclosures impact users' risk perceptions. So it's 2 prior studies, but as we go along in the PowerPoint, I am going to talk about how they differentiate themselves from these previous studies. So then the question is, how are we going to measure risk disclosures? The authors use the Perl code to download 10Ks from the NCC website and also to analyze the content of the 10Ks. The Perl code it separates the files into sentences and deletes the appendices. The Perl code also tags sentences that represent risk if the sentences includes one or more of these keywords. And actually, I had a problem with this approach because, I mean, may or likely to, this represents uncertainty, but it doesn't necessarily represent, it could represent either a negative or a positive outlook. But to be honest, I'm not sure. I don't really have a suggestion for this.
Well, does anyone else? I mean, this is like the stuff I want to talk about most because it goes to what we're doing in this class.
Right.
So are there other comments on this strategy?
I guess the risk is a neutral word, so it's just the risk just means uncertainty. So the word may could, I mean, it might be positive or negative, but
Right,
it's just
exactly.
uncertain. So I don't think risk is a negative word. So that's why the author doesn't mention negative or positive.
But I think, I don't know, for reading this paper, they say they want to test 3 arguments, but I think they were going for the divergence argument, which is what the paper supports. So I guess the way that I was interpreting the dictionary or the keywords that they come up with is that these words are going to represent risk, which is usually a bad thing. I don't know. I could be wrong. Yes.
And similar idea with COI, because if we interpret risk as a negative thing, and the thing is make the investors sure about that will happen and impact on negative thing, there might be low volatility, just drop down the price at the same all the consensus level, but they measure the volatility, so it's more close to the uncertainty rather than negative things, because they didn't see the change of direction, but just change of the ranges.
Okay.
But just like negative words, like when you have to like persist with that, like when I use my iPhone, when I just like type in like low, sometimes it shows like liabilities or
When you type what?
like low or high.
No, oh yeah.
And it gives me like liabilities. I don't know nothing about machine learning or those stuff. However, I think that when we could use those kind of technology, then we could not just search that one word. However, we could just predict the next word, get the relationships between those. Or
Yeah, there's a name for that. Is that like a fuzzy match? Like if you look at like you focus on one word, but you also look at the word that's to the right or the left of it.
like getting a neighborhood.
Yeah, right.
Getting a neighborhood and just.
Yeah.
We had discussed.
I think that would be a good approach actually.
It's hard to just specify the neighborhood.
Yeah. Yeah, like you want to look at the 2, 3 words or just.
Actually, our first paper was talking about that. Just negations, was it?
We had talked about the idea of looking at relations,
Yeah.
phrases. I think my concern was that it was another interpretation. I think it was they kind of manually, they based it off of the list and then expanded it.
Like
So
they read
one is kind of a manual
100.
expansion. There's
Yeah.
another instance of saying that there's just kind of their judgment call on what these things are. So that's just always, we've talked about that being a concern.
Yeah, it's just an approach they used. But I think, to your point, I think it could have been expanded a little bit more because, okay, this represents uncertainty, which could either be positive or negative outlooks, but I don't know, I thought it could have been strengthened a bit more. And therefore, how they measure risk disclosure this is the total number of sentences that have at least one of these keywords. So if a sentence has the word may, then the sentence is classified as expressing a risk. And then they say how they're different from the prior to research studies because they're looking at sentences and they're not looking at words. So they're saying that this helps to eliminate or mitigate the problem of double counting or even triple counting risk. Right, because if you have 3 words that you tag as risk or that represent a risk, then you're going to count 3 risks. But if you have 1 word and then count the sentence as risk, or 3 words and count the sentence as risk, then you're not double counting. And then they also expand for Lee because Lee has her dictionary or her keywords. And he has 6 of them. They I think they have 18 in this study. And then Campbell et al. They use the total word count in section 1A, so they're shifting it to just one section in the 10K. But in this study, they look at sections 1 to 14, so it's an expanded search that they do. And then they just provide more justification why they use a sentence, because this is the smallest unit of text that conveys an idea.
Are they citing the Campbell or Lick this paper before or after? Or they're citing?
They were citing, yeah.
Yeah, well, I mean, ideally I think item 1A is a good one to use, but since their data spans before item 1A was required, which wasn't until like 2005.
Oh, right, yeah, that was 2005.
So it's kind of a weird data set because we have a couple years with item 1A, this whole section of risks, which they could just count that whole section. What if those risks don't contain these words? Or are they just looking at the MBA data? Are they looking at the whole 10K or
The whole, well, not the whole 10K, but
all the
pretty
text,
much,
right?
yeah.
That's what it says. All the text, including the footnotes?
I think they're eliminating, they deleted sections 3 and 4 that has management compensation and those things.
Yeah, so I'm just saying it seems odd that the data set they picked as item 1A in some years and not in other years.
Yeah, actually that's a good point. Because they have 2 years of item 1A.
So they're using change in risk disclosure, but they're not. I don't remember if they were using like a relative risk disclosure, like we saw with like negative stuff, to like compare it to other items in like the larger set. Because I'm wondering if they're talking about trying to remove some of the volatility of like double counting, the counting in sentences, but I don't remember them mentioning anything about doing like a TF-IDF or some kind of leading system to complete against. And that I'm just wondering if that changes things. We saw that was effective in some situations. We're talking about
I guess I think it could change it, but they didn't do that in this video. It would make the argument stronger, I think. Okay, then here we have this table that has the average number of risk-related keywords. And I mean, I'm not surprised to see like may is at the top of the list. And then could and cannot. And then here we just have the changes in the number of risk-related words. And then in the appendix, they also provide examples of the keyword and a sentence. So I think in the first sentence, it's kind of blurry from here, but it had something that expressed some, I guess, some uncertain future outcome. So in the United States may not be profitable, so negative impact on future performance.
Do they provide do they check the sentences to see the ones they identify, how many are actually risk related and how many are not?
For the ones I don't think that's clear. I don't think that's clear in the paper. Maybe these examples are
Yeah, those are good answers, but I'm just curious,
Exactly,
like, out of 100 sentences, how many would be unrelated to the risk?
Right, yeah.
They count the risk sentence with the risk keywords that we want, and they also add the non-risk disclosure variable to the sentence without any risk model. If I understand.
Oh, yeah, that's true. So what they do is they tag these words, and then everything else they say that these are disclosures not related to risk. But I think your question is, do they like cross-check?
Do they just, yeah, I mean,
I don't
obviously
think
they have errors, right? Like,
Right.
Do they report on that?
No, they don't. Like these are perfect examples that you would find, right?
So, general question, so I never read the template manager part. Is it like the item says the company lost due to risk? I mean, if there are, would it be possible for them to regress previous years, like the word list, regress it on the next year's loss figure? And then, for example, they have 15 words, they just eliminate the words as insignificant relationship to the next year's risk. So that's more like taking a empirical methodology in the rigorous approach to what you find there that works. But I don't know if there's a figure that shows that.
Yeah, I mean, I don't know how many statements. I think they do potentially say, oh, we were unprofitable because this came to realization, this risk really happened. But I don't know if they would have enough of a sample size for that. It just doesn't seem like that's
For
something that
example,
would
if one of the figures, like a number, is like our company's loss due to risk in the year 2006,
Right.
then they can go back to the frequency of that 20 words, like I'm going to regress all this like frequency of 2016 the disclosure on 2017 loss due to risk. Then there's correlation, right? So
Right.
just look at which correlation is significant, then we can say that this is a better word character that is significant.
Yeah, that's a good suggestion, but I don't know how frequent this happens.
Exactly. So I don't know either.
I think it does happen.
Yeah.
Alright, so for the predictions, we start first with risk disclosures and stock return volatility. They suggest that if risk disclosures introduce unknown contingencies and risk factors, then users are going to diverge their predictions of future performance because this is new information that they did not know about before and could potentially be negative information. And then, so again, this is the divergence argument. And then for convergence, they suggest that if these disclosures resolve known contingencies, so if they already gather, the users already gather this information from other sources, and disclosures are clarifying this information, then users will converge in their predictions and increase their confidence level. So they predict that there will be higher return volatility during the first 60 days of trading after the filings, and then the opposite is predicted for the convergence argument, that there's going to be lower post-filing return volatility. Then they also look at the impact of negative stock returns, compare that to it's the ratio of negative stock returns to positive stock returns, because they expect these to be more volatile. Then for trading volume, they suggest that, and according to prior literature, that unexplained trading volume is the most reliable proxy for opinion divergence. So if risk disclosures and intention filings increase the range of investor predictions, there's going to be there's going to be more revisions. There's going to be differential belief revisions, and this is going to lead to more trading volume. And then they also predict that that investors trade more after the filings if they have lower confidence in their predictions. And then for the last prediction that relates to analyst dispersion, how far apart analyst forecasts are. This is consistent with prior literature that dispersion in analyst forecasts increases when there is uncertainty. And Null argument predicts that analysts are not going to change their forecast if they think that risk disclosures don't provide any useful information. And then for the convergence argument, then there's going to be less dispersion if the risk disclosures confirm what they already knew. And then they also partition their sample into firm versus industry to see which one is more informative. They hypothesize that industry-level risk disclosures are going to be more informative because disclosures at the firm level are going to be more boilerplate. And why is that? Well, that could be because entities may have the perception that if they provide specific information about their firm, that somehow this is going to give away their competitive advantage or confidential information that is not yet available to the public. So for the research design, they collect 10Ks from 1994 to 2007, and they merge different databases from CompuStat, CRSP, and then the analyst database, which I think is IBES. They have about 28,000 observations, and this is the model that they use. And then the Y, these are the proxies for risk perception by investors. So we have 3 different models that they run. Okay, before we get to the correlations, here we have a graph that shows the changes in risk disclosure. Clearly, we're seeing that it's trending up from the time that they started collecting their sample. In 1997, 1998, we see a spike, and apparently this is when the SEC requirement to, I guess, for companies to disclose risk related to assets and liability, when this took place, and then another spike when the Sarbanes-Oxley Act became effective. And then the last spike that we see, this is related when firms were required to disclose Item 1A risk factors. Yes?
It's funny, interesting, just right before every stock market burst, there's like relatively lower disclosure, right? Like the top 2K is the tank, and then that's the
Oh, yeah, right.
right the financial crisis in 2007. So apparently it's kind of like reverse.
It just goes up and down, and I bet after the recession, 2008, it just spiked back up.
Yeah.
When I just read the 10K 1A part of Apple, like it's very specific. Like sometimes like, you also have some timings like from some events which happen in like specific date before the 10K was disclosed. Actually, Dr. Mel also like told me about this kind of stuff before the timing periods. And the 10K like has details which is the passive, not the present. However, the stock price of 60-day period is actually after the 10K, after disclosed 10K. So we are talking about the stock volatility, about the disclosure which was happening before it.
Before and after.
They say, I'm not sure, but they say it takes time for the market understand and interpret
Right, to
the
incorporate
10K information.
So there's a time lag.
But I think
Yeah.
60 days a little bit somehow.
much,
But yeah, they
I'll give it in a couple minutes.
Okay.
You want to go over the test they did with the sentiment analysis in the end.
Sentiment analysis.
Yeah. They looked at negativity, right?
Oh, yeah.
They built their own negativity dictionary.
They didn't really find anything there.
Yeah, do you have
Actually,
slides
I
on?
don't have
Oh, you don't have
anything.
slides on that? Okay, we have 2 minutes. Right?
Okay, so do you want me to go through the results?
Whatever you think's most interesting.
Okay. These are just correlations. Nothing new. Okay. Then, okay, their analysis for volatility of daily stock returns. So here, they're pretty much finding consistent evidence that the more risk disclosures that entities disclose, the higher volatility. And this is the first model. And the second model is the same pattern, but we have additional control variables. And then models 3 and 4, this is looking at the volatility of negative returns compared to positive returns. And it's pretty much consistent with their hypothesis that negative returns are more volatile. But I didn't really get why they include risk disclosures that are not related to risk. That was one question I had throughout the paper. And then for trading volume, same thing. They find that more risk disclosures leads to more volume after the case have been filed. I did have a question about, so they have 2 different dependent variables. They have the log of filing volume and then the change in log of value. So I'm not really sure why, maybe I'm not understanding correctly, but I'm not sure why this is a dependent variable. I would think that this is something they need to control for, and it wasn't really clear to me why they're using it as a dependent variable. And then same pattern here, more risk disclosures, and more provisions for analyst forecasts. And then again, this is consistent with their hypotheses that the changes in industry level risk disclosures are going to increase users' risk perceptions for all of the proxies that they use for user risk perception. And that's pretty much it. They find evidence that supports their divergence arguments that risk disclosures are informative and they increase users' risk perceptions.
Okay, thanks.
This way, I would say, yeah, I love this way because yes, it's obvious. But let's go
So
back.
in general, though, just so you guys know, if you make an effort, like work as a group, get your work done before class, it doesn't have to be perfect. If you make a good effort, you know, it seems like you all have been doing that already. And then you get credit for that assignment. Okay. So go ahead.
So, first of all, I brought all of those because, the CS and those fantasy, as I said before, I did the assignment 1 and 2 from the beginning as Maurice Wade, just to follow up and make it easier for me because I would like to have those kind of for future research if I'm going to do it. So I want to make it as perfect as I can. And his way was really perfect, I tell you that. That's why we suggested to work from the beginning to Maurice. Right? Then after that, we started with cleaning their files. So this is my file, the main file, and then this is how this is my file now, like for cleaning, and then we clean the objects by doing those codes. So then after that, we have the progress as I like. We showed the time. I ran it 4 times. Like every time I run it to make sure that I had coding because I was working in it for 4 days. So every time I come, I have to run it again because my MacBook is different than so I had to run it again. So it took me for like 30 minutes, 53 minutes. I took only 10 case as a sample of my file. but I would say if I make it more than 10, it would take a long time. Maybe I'd like to put it for the next one. Then after that, here this is the dictionary. We import the text set, which is for the dictionary. It's big ways he told us that to import it to get the dictionary from the text sets. And then after that, we created the file or the word list that Professor Kevin asked us for. Can you see it, guys? Can make it?
No, we can see.
So we counted the words how Professor Kevin asked us for the census count and census average and syllabus count, complex words counts and index the file size. Actually, file size I had a lot of problems with it. I didn't get it. Abby, she helped me out with it, and she can explain more when we talk about how we get file size. And then after that, this is how it's gonna look like my file. Let me show you. This is the final result of the file. Wouldn't have it work with that. So let me make it bigger. So the company name type, form type, and then the CIK data file, and also the census counts, census average, syllabus average, complex words, packet exam. Also the file size. 410 cookies.
I mean, this is incredibly useful to be able to download the 10Ks. This is incredibly useful to be able to download the 10Ks,
Of course.
clean them up, and extract all the data and throw it in a CSV file, right?
Before this class, I think it's impossible. To be honest, for me, actually, I have no experience in coding. I never know that you can pull out information from website and do it. Yeah.
And at least, even if you don't feel like you're a good coder, by the end of class, you've seen enough sample code, and you'll all have access to this folder forever, right?
Exactly, yeah.
And you have enough sample code to do a lot of the work.
Actually, Aaron, he did like a Google Drive for our group. Or not, what is it, Dropbox. We decided we're gonna do a Dropbox for coding, and we save it for us for future.
Oh, okay.
So
Well,
even,
that's
yeah.
easier.
If that's
Smarter-
okay.
smarter to draw a
Yeah.
local copy. Yeah.
However, during this process, like our problem was that 10K has table, and those table when we just like do those cleaning steps, that table like still remains those codes on like a statement, so we don't know. However, like it has like a phone and like blah 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 numbers on it, and it's like really dirty. So the word count and the sentence count is all messed up because of those like remaining codes on it. So what we did was that we found the like common kind of like we're starting from the tables, and it was like different from the samples. But however, we just found the common words, and then we partition it, and we deleted the other part of it, and then like we just used the upper part of it.
Sure.
Yeah. But however, the problem was that it differed from the samples. We only use like 10 samples. So the first sample it had a different common words, and when we use like other samples, like, it also had different common words to just pick it up. So is there any way that like you can just pick those kind of common words automatically, or?
Sure, you can do this. Now, the most difficult for me, I don't know, but the most important part in text line, so and the most difficult to do is the cleaning the text. So it's very difficult, it's very complex. So we'll have defined just a simple function, and you can understand what it's doing. For a research proposal, for an application proposal, you have to dig more and find the patterns, find the difficulties of the files to clean it up. Okay, just a simple function. I have a function that make just keep all the letters, remove the HTML index. But for a more serious proposal, you have to spend more time developing this function. For what happens for this assignment in the first function I share to you, I remove all punctuations. If you're not calculating Fox index or index, you don't need the dots. So the punctuation is just so I remove all. For this kind of assignment, we need it, so you have to process again. But I have saved it. So next time, just upload what you need with punctuation or without punctuation.
One of the things that I was doing that we had talked about was that I went back to like that after that first step and said, okay, I'm going to clean it the word way so I can get the negative counts, but I'm also going to clean it the way that I can tokenize it for sentences. And then I also need to clean it a different way to deal with other questions. And so the pickle file got really big.
Yeah, you can save a different.
Right, so you had to kind of have multiple versions of it, and then you have all these things and you're going, okay, now I got to think about how to join them back in, which is good, but there's a lot of opportunity to lose it. So like this approach, my for loop was a lot more broken out. Like some of the things I was doing as apply functions because I was trying to avoid errors. So if that something in there didn't work, I didn't want it all to be tied together in a variable that lost. But at the same time, then you're making, I ran into the issue of like I couldn't figure out how to get my apply functions to use multiple variables, like pass multiple variables from the pickle file. So if I defined a function that had multiple arguments, I couldn't get like lambda functions to work to send multiple arguments through, so I couldn't apply it. So I had to just turn it at the last second, turn it all before like direct applications of like list.
Yeah. In the previous segment 2, I create a function with more than one argument. So you can pass more than one argument in apply. Yeah, take a look at segment 2. In the end, I create just for sample, just for demonstration too. But you can create a function with more than one argument.
Okay, because everything I was finding online said you had to use like lambda functions, like create like a
I know. But I really don't know if apply works. Should work.
Yeah, because I was thinking like if you had a word count and the number of sentences and you wanted to pass both of those, I think the issue was running into was losing the count of which one to pull from.
Yeah.
But
You have to text.
I just turned it into two lists and then did division.
Yeah, you have to try. But you can create there is a lot of things to do, right? So.
Hey, I was wondering how you did for the file size.
On file size, we use the function called system get size of, which is actually found by Arian, and then we.
It's getting the size of the string, only the strings, not the text file.
It's. Yeah, I believe it gets the size of the using memory, right? The size of the corpus in memory, right?
Yeah.
With how much memory it is using.
So
it works.
This was after you already took out all the HTML.
I applied it to the original because I still have that in the file.
You
still have the original first version on it.
Yeah. I think what they did, the cloud document was the actual file.
Yeah.
Like right at the beginning, as the actual down, they kind of like as it gets put into the file.
Right.
So it's just earlier stuff.
Yeah, I have difficulty to organize or capturing the abbreviations with the dots. So is there some recommendable dictionary for the abbreviation list?
Can you go what? We just deleted it.
Yeah, I have abbreviation list on my computer.
On my computer.
You mean those
that I use for that
stuff?
We had a lot of discussions about that, like having abbreviations, but then one of the things I think we came up with was that just the fact that I would want to dig more into like in the future if I was using this, like the
think it's worth to spend some time with studying analytic. They have a lot of things already done. There is, for example, what you did now. There is a lot of functions doing. For example, the text types do everything there. And analytic, there is a lot of functions, a lot of treatment. It's already done. You just have to know how to use. So it's worth spending a little time studying analytic. I have to do it this way.
Yeah, because I think that was the thing that I kept running into, is just not knowing what they did handle and being worried that they couldn't handle a certain case, but then knowing I couldn't handle it either. So not.
That a lot of you are already using regular expressions in your code, so maybe this part will go really fast. But I need to make sure we're all on the same page, right? So who wants to tell me what regular expressions are? Okay.
A regular expression can, I think, is a pattern to describe the text. For example, I don't know how to describe, but I guess it can be used to find some certain text in some certain pattern in a text file.
Yeah, that's right. So a regular expression is a pattern to match text. So this is one regular expression, the letter A. It matches the letter A. Very simple, right? Okay. AB matches AB. Now the star modifies an A. So A star matches 0 or more A's. Okay? So nothing, A, lots of A's. A plus also modifies an A. So A plus matches 1 or more A's. So it's almost like a star. That's 1 or more A's. There has to be at least 1. The parentheses group a group that can be modified together. So AB in parentheses with a star means that A and B have to occur 0 or more times together. So matches nothing, AB, but not ABA, because there's no B in there. Anyone? Everyone? Good.
What's the difference between A star and A plus?
So A star means the A doesn't actually have to be there. So it matches 0 to many A's. And a plus is 1 to many.
So 0 will be matched with this A star.
Yeah. Or, nothing will be matched. You'll see, I have some worksheet. A dot is a special character that matches anything, basically. Almost anything. It depends. So like in Python, when you're using a dot, it matches anything but a new line character. But you can change the flag so it does match a new line character. It's an option. Okay. So one dot matches 1A, 1 4, 1 pound sign, 1 parenthesis, 1 capital A, capital B, 1 of anything, basically. And 1 dot. Now if you want a dot to match only a dot, an actual dot, what you do is you escape it by putting a slash in front of it. A backslash. So a backslash dot matches a regular dot. Sometimes a backslash makes a character special. Like a backslash W matches any alphanumeric character. Any A, B, Z, 1, 9, but not special characters. But a regular W would match W. Are you guys familiar with all this, or is this new? Somewhat. Okay, good. Yeah?
Yes. I learned this first in the PhD seminar class, right?
Oh. You know this. So look, here's something useful. So /W plus matches any numbers, at least 1 or more alphanumeric characters. @ symbol matches an @ /W plus matches more alphanumeric characters, at least 1. A /dot, which used to be a popular website, matches just a dot. And then COM matches COM. So this looks like an email address, right? So this matches this email address. But why does it not match this email address? So this dot right here? Right. So /w plus matches came off, then the at, then /w plus, then the dot, then the comma. Pretty neat stuff. This phone number actually isn't exactly correct, so I'll just point out a few things. So a question mark, well, a slash parenthesis means it matches an actual parenthesis. See how parentheses are here? Here are used to group the A and B together. But a slash parenthesis matches parentheses, right? The question mark means 0 or 1. It's like a star and a plus, except it's 0 or 1. So it's optional, basically. And then a 3 in these curly brackets. Well, okay, sorry, I skipped one. The /D means any digit, 0 to 9. And then the 3 in curly brace means exactly 3 digits. It's like an area code, right? A dash means nothing unless it's inside square brackets. So here means a dash, but it's optional because there's a question mark. Then more optional, no, here you need 3 Ds, another dash, 3 Ds. But this isn't exactly right. I think I messed up with the parentheses. So I'm not going to try it out in real life. This works. I know this works. This is a Visa credit card. So the caret in the front means we're looking for something that starts with a 4. So that's what the caret means. It starts with a 4. Now we have these square brackets. Those mean it's like a big OR statement. 0 to 9, any one of them, doesn't matter. So here the dash means something different than this dash, right? It doesn't. This is not matching a dash. It's saying 0 to 9 in square brackets. And we want 12 of them. It could be, if the first one's a 0, the next one could be a 2, the next one could be a 5, the next one could be a 2. It doesn't matter, right? We need 12 numbers, 0 to 9. So we want a 4, 12 numbers, any numbers. And then this stuff is used to make sure that it ends, I think, after 3 more numbers. I'll have to look that up. But this 0 to 9 and 3 more numbers means 3 more numbers. But basically, it has to be 16 numbers. Now, if you don't take care about how long your number is, it might match 16 numbers out of 18 numbers, right? But you want it to be 16 and only 16 numbers. So that's what these question mark things are doing here. They're making sure that it starts with a 4, finds 12, and it ends with 3 numbers, any 3 numbers. So if you look at your Visa card, I think it starts with a 4. And American Express starts with a 3. And then it has a 4 or a 7. And then 13 other numbers. Okay.
What's the dollar amount?
Yeah, I think it's also something about ending with those 13 numbers. I need to look that up. I should look that up before I teach it. Yeah.
Are they different to 2 and 3?
What?
Are they different? Are they different? Oh, okay. I was just
It
wondering.
depends on the Python, for example.
What?
The regular expressions.
So, regular expressions are basically language independent. They can be implemented in most any programming language with slight differences, very slight differences in syntax. So this is useful if you like programming. So I built a regular expression function in VBA and Excel, so my students could create regular expressions easily in their workbooks. All right. So what else do I need to tell you before you start on this worksheet? So they are case sensitive, right? So there's another or symbol. So this would be A or B. Right? A or B. Which is very useful. Because you can say, I mean, this is equivalent to this, right? This marker. This is equivalent to this. But this is useful if you want to do something like A, B, C, or D, E, F. Okay, all together. Okay. Now, another useful thing is to say, put a caret inside of the brackets. You guys have done this before, I saw it. What does that mean? This matches anything except an A or B. So you can do A or B, you can do A, Z, you would match anything but A to Z. And this character matches a space or a tab. And Mauricio keeps telling me it matches a new line also. Is that right?
Yeah, this is for special characters, right?
It's spaces, tabs, and new lines.
Yeah, space, tabs, new lines.
Yeah, I think that's it. I don't think it's other special characters.
I can check
you think
this.
it is? Like, I don't think so.
I can check this.
All right, check for me. All right, so let's quickly do this worksheet. Which of the following matches? A, B star A. So anything that starts with an A, yes, and then it has to end with an A. So they all do that. So there has to be either nothing between the two or an A to B pattern. So 1 does not work, 2 works, 3 does not work, 4 does not work, 5 does work. So 2 and 5? Okay. A, B plus C question mark. So there has to be an A. So 4 does not work. There has to be at least one B. So 2 does not work. There has to be, it could be a C, 0 or 1 C's. So 3 still works, and 1 works, I guess. 1 and 3? Okay. A dot B or C plus. So that means you have to start with an A. That's fine. And then there has to be something after the A, so that's fine. And then there has to be in the third space a B or a C, at least 1. So 5 does not work because there's nothing in the third space. And then 6 works. 4 works. 3 works, and 2 works, and 1. Everything but number 5. What I got? A, B, C, or X, Y, Z.
But the plus sign must be something else after the third character?
The plus sign?
Yeah.
1 or more.
1 or more. So, should be at least 4 characters? No?
No, 1 or more B or C.
Okay.
Yeah. And then number 4, I think I maybe should put parentheses around this to make it more clear, but ABC or XYZ, so 1 or 2. Number 5, so A to Z, any of those letters at least once. So 2 does not work because it's capital H, right? So you can eliminate that. And then it has to, looks like it has to end with period, question mark, or exclamation mark. So I guess 3 doesn't work because it doesn't end in that. 4 works. 5 doesn't work because there's a space in the middle. There's nothing matching the space. 6 works. 7 does not work because there's that period, which isn't matching later. Yeah, I think.
So then if the slash dot is looking for period specifically instead of period being all alpha.
Right, right. And same with slash question mark.
So 7 doesn't work because this.
7 doesn't work because it only matches once the period at the end. You understand? So the pattern says it has to be A to Z, 1 or many times, and then a period, question mark, or exclamation mark. So what number 7 is, it doesn't match that because it's A to Z 2 times, then a period, then a question mark. Yes?
For, I guess the slash period slash exclamation point question mark, why do you need 2 slashes?
Okay, so the slash period means the period is an actual period, not a special character. And same with slash question mark. Like the slash goes with the period, the slash goes with the question mark. So it's a question mark, not a 0 or 1 modifier.
Okay, I guess I thought if you had the slash period question mark or exclamation point, I guess I thought it would be enough, so I didn't see why you needed 2 slashes. I don't know.
So Mauricio was showing me today where you didn't have the slash period, so that's why but it still works inside the square brackets?
Yeah, it still works.
Because it's in the square brackets.
Oh, no.
Yeah, I try outside, inside to work. They're both. I really don't know. I have to check again.
All right, so
should be outside, right?
The point is we're able to read regular expressions. There's a slight imperfection. We'll know when we try to run our code. Okay, which of the following matches this? So we want any letter, capital or lowercase, 0 or many times. So that tells us very little. And then we want any character except a comma once. And then we want an equal sign. So we can look. 3 does not have an equal sign. Number 2 has a comma where there should not be a comma. And number 4 has the 7 in there. So that doesn't work because you can't. It's only letters. Is that it then? So 1. Yeah, 1, 5, and 6. Yeah, space is okay. Space. 1, 5, and 6. All right. Which of the following match? So it starts with a lowercase letter, so we can get rid of number 1. Then some punctuation mark, so we can get rid of number 3 and 6. Then a space character, 1 to many. So it has to be at least 1 space. I don't think we eliminated any of that. And then a capitalized letter, so you eliminate number 2. So we're left with number 4, is it? And 5?
Yeah,
4 and 5. Okay, which of the following matches? So very, that's fine. Very in a space. Fat in a space, optional. Tall or ugly, man. So 2 doesn't work because it doesn't say very. And that's optional. So it looks like all of them except 2. 1, 3, or 4. 1, 3, or 4, yeah. Okay.
parenthesis or just like the previous one, ABC or something like TALOU or TOESF.
Yeah, I think the parentheses need to be there for number 4. But the way number 8 is written, it's not L or U, it's tall or in parentheses. Yeah, you put it in parentheses like that. Number 4, I think I should have put parentheses around the ABC, XYZ. But, so 8 means, yeah, tall or not L or U. Good question. Number 9 matches left angle bracket. They all have that. And then anything but a right angle bracket. One or many times. And then a right angle bracket. So 4 doesn't work because there's nothing in the middle. And 2 doesn't work because there's a right angle bracket in the middle. Which is not supposed to be. So 1, 3, or 5.
In question 8, why the first one is they don't have total items?
Oh, you're right. Question 8, number 1 is not right. I said it was? Yeah, I get confused. I'm counting on you guys to sort things out. So yeah, number 8 does not have taller up. So good point. Okay. Well, regular expressions are very useful, so let me give you one example. So this will help with our homework exercise. So what we're going to do is use regular expressions to parse a document. So we're going to find a piece of text. You know, you've downloaded a whole 10K, right? But sometimes you just want one section of the 10K, like the MG&A or notes to the financial statements, right? So you can use regular expressions to parse 10Ks. But what we're going to do is something a little bit easier. We're going to parse an XBRL instance document. Okay? It's very easy because XBRL is so, the purpose of XBRL is to have a uniform way of communicating information electronically. So all the tags in XBRL should be perfect, you know, ostensibly, right? So it's really easy to parse XBRL documents in some ways because all the tags are correct. Now, HTML, what your guys' 10Ks are all HTML. Somehow people figured out, 50 ways to show the title of the management discussion and analysis section. So you have to account for all the different ways of presenting that section when you're looking for it in the text, so you can suck out what's after it, And before item 8. So if you want what's between item 7 and 8, you have to account for all the different ways of displaying or of writing item 7 in HTML. So it's much more difficult than XBRL. So let's go ahead and go to Edgar and download a sample document, an instance document. So are you all, who's familiar with XBRL? Who has no idea what it is? Okay, so there's nothing. So basically, XBRL is an agreed upon set of tags used to send, it's like XML, right? These tags are agreed upon and then used to communicate electronically financial statement data, or data that's usually in the financial statement. So I'll show you some examples. Let's just go and look at one. If I were to browse, if I were to Google like SEC Edgar, and I want to go to Apple's by using their ticker search, I can just type in the ticker for Apple. I can search for their 10K, right? I can look at their documents and find their instance document. So the instance document should have all of the financial statement data, all the numbers, and that data should be tagged. So if it's total assets, it'll have a specific tag, US GAAP, assets total, and then a number, and then a closing tag. Really easy to find. There's other information too. So there's an instance document. So if you want to look at this interactive data, pill, button, this is built off of the XBRL data, right? So it's interactive because I can click on these, on everything here in the table, and it'll give me like the name of the tag associated with it. So let's go to financial statements, consolidated statement of comprehensive income. Let's look at this net income, okay? Click on it. There's information related to it, like a definition. If you look at details, it gives you the name of the tag, net income loss. So I can easily go into an XBRL document, search for this string, US GAAP net income loss, in bracket, search for the open tag, close tag, suck out the information in the middle, and I should get this number if I also search for the right period. What is cool about XBRL is they also tag the notes to financial statements, which have a lot of text. So, for example, I'm interested in a couple of these for various reasons, and one is income taxes. Now, if I click on the income taxes tag here, let's see what it says under details. The name of the tag where you'll find all this information is called US GAAP Income Tax Disclosure Text Block. So this would make a really great data set for one of you if you're interested in the text in this footnote in the financial statements. All you have to do to get this data from the XBRL documents is first download the XBRL documents you're interested in, which is just as easy as downloading HTML documents, like the 10K. There's an index file. You use the exact same code, except you use different index files. Download the XBRL documents, and then you just have to suck out this text, this block, this text block, and you'll get all this information, lots of tables, but there's also a lot of text. Right? And maybe you want to do some simple analysis on the tone in the income tax text block. Maybe you can think of something a little better. Okay. So what I want to show you how to do today is how to extract this section out of your instance document. So let's download an instance document onto our computers somewhere where you can get to it. So if I go back, right click on this instance document right here. This has, the instance document has all the data in it, okay? All these other XBRL files kind of just give more descriptions of like what types of tags are used, what the tags mean, and so on. But this instance document will have all the text blocks in it. So if you're interested in maybe your research paper you do for this class, if you want to look at the different text blocks available, just go under notes of financial statements and look at all these different notes. So the other one I'm looking at is commitments and contingencies because it talks about all the lawsuits that might be coming up, or if there's any product recalls or warranty issues that would cause the company to maybe lose money in the future. They talk about it in this text law, which could be really interesting. All right, so if you, yeah.
I think you can get the references here. Can you go back? Yeah.
Go back where?
Yeah.
Click on this?
Yeah.
So I click on this, and then I click on here,
Oh.
and I look at details,
All right.
and it gives me the name of the text block. Right there.
Yeah.
So that's the critical information I need right there. So let's assume, you can imagine now having 1,000, 10,000. I downloaded over 40,000 XBRL files. If you want them, just get them from me. I can give them all to you because it took me days to download. It's like almost, I don't know, like it was just an instance document. I think it was like 700, 800 gigs. I have it on a hard drive, so that's what you want to do.
There is a special collection in the use of XBRL file. So just go to Google, type XBRL RSS.
RSS? Oh.
RSS feed. And you can find out these XBRL file.
And so it always updates.
Yes.
It helps you download it too. It gives you the new file locations on Edgar?
Yes.
Oh, so that's for for updating your data set, right? Or
right. Just go to XBRL RSS feed.
Okay, I'll try it.
XBRL RSS feed.
Yeah.
Find out that one.
This one?
First one, the second one is the same. When you go further down, you can find out the names.
So an RSS feed is just, it always updates, right?
Right.
Daily or?
Every second.
Every second. So if there's a new, okay, so you're constantly monitoring this RSS feed. If the new file pops up, you download it.
Right.
That's what you do? Yeah, Juan has, so I'm a little shy talking about XBRL in front of Juan. He's the XBRL master. And so is Mauricio. You're doing XBRL research, right?
Yeah, my dissertation is using XBRL.
Yeah.
And there is an XBRL archival that's the most they usually provide 10 most least defining, and you can find that archival. There is a directory. You can find out entire XBRL file, list of XBRL file from the archive. So you can type XBRL monthly, archive FSS, FSS, and you can find it.
So thank you, Juan. If you have any questions about XBRL, go to Juan's office. Or call his cell phone. What's your cell phone? Yeah, so you downloaded the file? Did you guys download an instance document yet? I need you to do that for our interactive coding session we're going to do together. So I need you to download an instance document. I use Apple. You can use Apple. They're both recent 10K. I downloaded it. I saved it on my computer. Okay. So I will go into Anaconda.
How do we save the
You could right click on the link and save link as. Yeah. Okay. So already did the code. See, this is how I used to code. I still code like this. So first thing I want to do is say where is my file? Okay, so I can say XBRL file. Then open your file. So mine's right here. Read it. I'll read it in. How do I get this to? Okay, so I opened it, I read it in. Alright, let's see what I want to do next. So what I can do is I can create a pattern, regular expression pattern. So maybe I need to import, above this I need to import regular expressions. Okay, so say pattern equals, so I want to write a pattern that's going to capture that whole block of text. Okay. And you can do this different ways. I'll just do this for this one. So pattern is equal to, how about the name of the text block, which was that's the name of our text block, right? So we're going to search our instance document. We're going to look for this, right? Now the tags have, this is the name of the tag, but then there are a lot of, what are they called? Properties after the tag, before the tag actually closes. I don't know what those say exactly, all right? So I'm just going to ignore them for now. So we know this is how it starts, though, and we know how it ends, right? A close tag. It's very similar to this. So I could just, I think that's a backslash. Or is it a forward slash? Oh, forward slash. Okay, so this is how it ends. So I basically want everything in between here, the open tag, and the close tag, right? So how do I get everything in between? What can I use for regular expression? Dot. So dot what? Dot star? Okay, dot star. Just like that, right? So hopefully this works. If it doesn't work, we'll fix it. But what you were saying is we're going to search for this tag. We're going to search for a dot star, like which matches anything basically. And then we're going to search for the close tag and be done. Okay? So we're going to use a search function, which would be, I did it a little differently. So if you go, I have a resource I always go to for regular expressions in Python. Maybe you found the same one I use. Maybe use a different one. I just type in Python regular expressions, and this document comes up, and I just use this, right? So I want to use the search function. This one right here, read.search. So this will, this says you need two parameters, the pattern that we made and the text. And what it returns is a match object, which you can then go in the match object and find the actual text that it matches. Okay, so let me show you how. We only have 7 minutes, so I might not ask questions, I may just do it. So we'll save results is equal to read.search. Now there's a match function too, read.match. The match means it only matches at the beginning of the string. We want to search in a string. There are other useful functions like find all, which would give you a list of all the matches. But we're going to just search for one thing. So read.search, then we want the pattern and the text, right? XP or and we're going to print the result. If it found something, it'll return the name of the match object. If it found nothing, it should say none. Okay. So, right. So let's see if I run this. I'm guessing it won't work. File not found. See? Oh. Wow. And messed up. Alright, let's check. Oh, it did work. It should. Oh, let's hope it did work. So apparently the dot matches new line characters, which I didn't know would be the default. But let's just print what it matched. So to do that, we could say print result.group 0. But we don't want to print the whole thing, so let's say, 0 to 1000. Of course, maybe in Anaconda it doesn't print the whole. Okay. And here, we will print out the first match, like group 0. And let's see what it gives us. Okay, you see it worked. Now it's in HTML, you guys know how to clean that up. But it worked, right? So I can look at the last part of it and see if it gave me the end tag. Yeah, so the end of it has the end tag. Okay, that's good. So I was able to extract from our XBRL file that block of text. Now let's say we want to be a little fancier. Maybe we just want to extract everything in between the tags and leave the tags off. So we can play around with parentheses in our regular expression. So let me show you what I mean. So we know that there's something after this tag, like some parameters or some properties, right? And then we know that it ends with the right angle bracket. And then we know there's stuff in between the tags, right? So I'm wondering if this will work. This could break our code. Too bad it didn't break our code. Because sometimes you have to worry about these dot stars being too greedy. So what that means is this might match, you know, everything like more than you want it to before it matches this right angle bracket. And a way to prevent stars from being too greedy is to put a question mark after a star. Oops. Dot star question mark. So now what this would do is it would force it to match everything up until it finds a right angle bracket. Okay. So I had that in my code, but apparently I didn't do it. Now let's say we want to just pull out this piece right here, right? Everything in between the brackets. So we can create a new group in our, and all you do is put this in parentheses. Okay. And now we have a new group. We can get the second group, group 1. And if I print that out, it shouldn't show the end tag anymore. It should show only this part right here that comes right before the end tag. Okay? So let's memorize what that is. Against U.S. taxes. Run this. Yeah. Against U.S. taxes. So that way you can be a little more specific with what you want in your results. Nice little trick. Any questions? Just 4 lines of code. And I had so much more planned. I think this is enough information for you for the assignment number 4. Assignment 4? Okay. I'll share this code on the platform. So your assignment is to download, let's say, 100 XBRL files. Just 100. Okay. And it's very similar to how you download the HTML files. Almost identical. This. All right. Here again. I'm going to throw this to you, and then you throw it in the garbage.
Okay.
Okay.
I was a catcher.
Yeah.
In
So
my
download 100 XBRL instance documents for the 10K. 10K instance. There's 10Q ones also, right? Yeah, we want 10K. And let's say I want you to extract two different footnotes. And what should we do? Clean them up. Clean them up. So clean HTML. And then what should we do?
That's it.
What?
That's it.
Yeah, I want you to do something. Hurry, we have 10 seconds. Then someone's going to come and pick me up. What's that?
Let's have an easy week.
An easy week? Well, what are the measures have we already done? A fog index? I hate fog. That was only one time. Never do that in your life. Okay?
Negative words.
Okay. Negative words. Negative score. I want a ratio of positive and negative words. Okay? If you're going to do that, I want one of your text blocks to be commitments and contingencies. So one is the issue. clean HTML, then I want a positive score, which would basically be, there's 3 scores I want, okay? Positive score, you're going to do the number of positive words divided by a total number of words after you take out the stop words. Okay, take out the stop words. So, don't include stop words. Negative score, same thing. Total number of negative words divided by total number of words. And then I want you to also do a net score. So positive minus negative over total number of words. So net positive. So subtract the negative from the positive. Okay? That's what you'll see in some papers too. Any questions? Okay. Thanks. Next week, advanced regular expressions. You want to teach that one?